Yeah, hi there. In this tutorial, we are going to cover generators in Python. So before we begin, before we come to the term generator, we have to understand a couple of other terms. The first is iteration. So what is an iteration? So iteration is a repetition of some kind of process over over and over again. So basically, it's like let's say we have a list of elements, and if you want to print each element of this list, so we'll say that we are iterating over this list and we are printing each element using this, let's say, for loop. So this is called as iteration. So we loop over through each element of this list and we print each element. So this list is an iterable over which we are iterating. The process is called as iteration. So the next term is iterable. So what is an iterable? Iterable is an object, for example, list in this case, that we can loop over. So it is capable of returning its members one at a time. So that's the key definition of an iterable. Now comes the next term. What is an iterator? So iterator has exactly one job. What it does, it returns the next item in the iterable. So how it returns the next item? It will return the next item when we pass an iterator to a next function. It will return the next item. And how to create an iterator? So if we pass an iterable to an iter function, we get an iterator of it. Okay, so the thing is, we we call an itr function, and to this itr function we pass an iterable like a list, and we get an iterator of that list. And then to the next function we pass this iterator, then we start getting each element of that iterable until we reach the end. At that time, an exception called as stop iteration exception is raised. So let's see an example of this. We have a list of greetings. Now, since this is an iterable, because we can loop through over it. So if we pass this iterable to a function iter, what we get is an iterator. So this iterable is passed to iter, we get an iterator, and we know if we pass an iterator to next function, we get the next element. Since we are starting, so the next of this iterator is high because it is starting from here, so it will get high in the output. And if I do next again, we will get hello like this. Now there is a term called as iterator protocol. What it says that iterators can be passed to itr function and we get an iterator from them. We have already seen this, so we are passing an iterator to itr function. What we get is an iterator. Next rule says that an iterator can be passed to the next function, and what we get is a of next element of the iterable, or we get an stop iteration exception once we reach at the end. And the third rule says that whenever we pass an iterator to an itr function, we get the iterator itself. And the inverse of all of these three rules is also true. Then this is called as an iterator protocol. So the inverse is that anything that can be passed to iter without an error is an iterable. So if we are able to pass anything to ITR without an error, then it means this is an iterable. And anything we are able to pass to the next function without an error except for the stop iteration error, then it is an iterator. And if we do the ITER of iterator, we get the same iterator. So that's the inverse of this. So if all these rules holds true, then it means we are following the iterator protocol. So let's take one example. We have a string. We know that we can iterate through each character of a string. So it's an iterable, and we are passing this iterable to iter. What we get is an iterator. Now we also know that if we pass this iterator to ITR, we get the same iterator. Let's say we store it in ITR2. To compare ITR1 and ITR2, what we are doing is we are printing ITER1 is ITER2. That is, if both are the same iterator, then we are getting true. It means this is the true. Since it is true, it means that itr1 and itr2 are the same iterator. So if we print next of itr1 and the next of itr2, we will get h and e. Okay, now let's say if we want to print a list of elements without using the for loop, then how will we do that? Let's say we have our own, we create a user defined function called as print each. In this function, we are passing an iterable. So the first thing we do is we create an iterator. How do we create an iterator? We pass this iterable to itr function and we get an iterator. Then we are creating a while loop, which is an infinite loop because we are saying while true. Then within that loop, we are specifying the try and except block. Within the try, we are uh, getting to the we are passing this iterator to next function to get the next element, and we are printing that element or item. So once we reach at the end, then it will raise an exception called as a stop iteration, and at that time it will come to this except block, and there we are breaking this loop. So in this way, it will keep on iterating through each of the element of the iterable, and until it reaches the end. At that particular time, it raises this exception, and there we are breaking this loop using the break. So, and if we pass to this print underscore each function, the simple list, we get the list of values like 1, 2, 3, 4, 5. So this is exactly what happens when we call the for loop. So all these things happen internally and behind the scenes. We don't know about it. We just simply call the for loop. But at the back end, it actually for loop it uses the itr function to generate the iterator of the iterable, and then it uses the next of iterator to extract the next element until it reaches the end, and at that time stop iteration exception is raised. Now we come to the generators. So Python generators, they generate values one at a time from a given sequence. So instead of giving the whole the sequence at a time, so a basic difference between a generator function and a normal function is that generator function will have syntactical difference is that generator function will say yield and it will return the value instead of the return and return value. So the key difference is that whenever we're calling a normal function, it will, let's say if we are passing using this normal function, if we are reading a file, for example, then it will read the entire file at once and it will store it in the memory. Now, let's say if the file is very huge and it's so huge that it can eat up our all memory, then we don't want to read the entire file at once. In such case, we can use the generators. So what generator will do, it will read each record at a time from the file, and we can perform the operations on it, and then it will read the next record. In this way, the memory usage will be very efficient because it's not reading the entire file at once, and we can read a huge file without breaking anything, because that's what generators do. They use this concept of reading or iterating over each element of an iterable once at a time. So let's say we have creating a function called as student data generator, in which we are passing a file and we are opening this file and then yielding each row. So what it will do, it will so and then using this for loop for student in this data generator, we are passing the file name and then printing the student. So what we are doing is we are calling this function student data generator, and we are passing the file name. In within this function, it will open the file that we have passed, and it will yield one row at a time. And the one row that we are getting is stored in this student, and we are printing that row. So in this way, we are reading one row at a time from the file instead of reading the whole file at once. Now comes another method to create the generator is the generator comprehension. Like we have list comprehension, similarly we have generator comprehension. The syntactical difference is that we use the parentheses for the generator comprehension instead of the square brackets. Okay, now one more thing we can do is we can do a chaining of generators. Now let's say we reading this student's file now, and our requirement is that to read the file. And since this file is having a lot of records and each record is comma separated, we want to filter and select only those records which belong to students of class 10th, and for such records we want to extract only the name of student. So that's our requirement. Okay, so let's see how we can use the generators effectively for this use case. So what we are doing is you are using the generator comprehension, and that is we are using this parentheses, and we are saying for line in open file name students.csv, and this line, and it stores in records generator. And then for each record in this records generator, we are just splitting the record on the basis of comma. It will give the fields, and for fields in for f in fields, if the first field, that is the field at index 1, is 10th, belongs to class 10th, then we are just simply extracting the value at the index 0, which represents the name, and we're storing it in class underscore x generator. And then for each student in class x, we are just simply printing the student. So in this way, we are creating a chain of generators, and once this for loop runs, it will call this class x generator, which will call this generator fields, which will use this record generator, and which will read each record at a time from the file. So in this way, instead of reading the whole file at once and performing the operations on it, what we are effectively doing is we are reading one record at a time, filtering, splitting it, and then we are filtering the record, and we are selecting those values which are as per our requirement. So that's a very good use of generator to make the optimal use of memory. So that's it for this tutorial. Thank you.